Have you ever just stopped and thought about Wi-Fi? I mean, really thought about it? 1 second, your phone is just a piece of glass and metal, and the next, you're streaming a movie from halfway across the world with no wires attached. It feels like straight-up magic, right? Well, it's not magic, but it is some of the coolest science out there, and we're going to pull back the curtain and see exactly how it works.
So yeah, that's the million-dollar question, isn't it? How does the entire internet, all the websites, all your emails, and let's be honest, an unbelievable number of cat videos literally fly through the air and into your devices? Let's break it all down.
All right, to get started, we have to talk about the medium itself. And no, it's not some kind of sorcery. It's actually a brilliant use of something that's already all around us, all the time. Good old-fashioned radio waves.
At its very heart, Wi-Fi is just a cool brand name for a technology that sends information using radio waves. You can think of it just like the radio in your car, but instead of broadcasting music and news, it's broadcasting the internet. These waves are part of the electromagnetic spectrum, the same family as visible light. They just operate at a frequency our eyes can't see.
Okay, so for this home radio station to actually work, you're going to need two key players. Something to broadcast the signal and something to receive it. In the Wi-Fi world, that's your router and, well, whatever device you're using.
Let's talk about the router first. Truly the unsung hero of our modern lives. This little box is basically the air traffic controller for your entire home network. It's the critical bridge between the physical, wired internet pipe coming into your house and the invisible, wireless world where all your devices live.
And what it does is actually pretty simple, at least in concept. First, it grabs the internet from that physical cable coming from your service provider. Second, it acts as a translator, converting all that digital data into radio waves. And third, it just blasts that signal out into your home, waiting for your phone, your laptop, or your smart TV to pick it up.
So, the router is broadcasting. Great. But how does it actually manage to cram something as complex as a whole web page or a 4K video into those invisible waves? Well, this is where it starts to get really, really clever.
Wi-Fi actually uses different radio frequencies, and you can think of them like lanes on a highway. The 2.4 gigahertz band, that's kind of like the old local highway. It has a longer range, and it's better at punching through walls, but it's also slower and way more crowded with traffic from things like your microwave or your neighbor's cordless phone. Then you have the 5 gigahertz band. That's the brand new, wide-open expressway. It's way faster with a lot less traffic, but its shorter waves mean it doesn't travel quite as far.
Now, before we go any further, just remember this one simple thing. Every single piece of digital information you've ever seen, an email, a photo, a video game, it all gets broken down into a super simple language of just ones and zeros. That's it. The whole challenge is just getting that code onto a radio wave.
And here's the solution. It's a process called modulation, and this is the real magic trick of Wi-Fi. The router takes those ones and zeros and translates them into tiny, incredibly fast changes in the radio wave it's sending out. It might change the wave's height, or its shape, or its phase. It's kind of like a super high-tech Morse code happening billions of times every single second.
Okay, so you have all these devices in your house, all trying to talk to the router at the same time using these radio waves. Without some rules of the road, it would be total chaos. So how does your network keep everything organized and stop it from turning into a giant mess?
Everything stays orderly thanks to a protocol with a very long name, CSMA/CA. Now that is a mouthful, I know, but all it really is a system for having a polite conversation. Basically, before your phone speaks, it listens to make sure the channel is clear. If it is, it sends its data. If not, it waits a random amount of time and tries again. This simple rule of listen before you talk prevents all your devices from shouting over each other and scrambling the data.
So that handles the traffic jam problem, but it brings up another huge question. If these signals are just flying through the air, through your walls, what's to stop your neighbor from just listening in on what you're doing?
And the answer to that is encryption. When you type in your Wi-Fi password, you're not just getting online, you're giving your device the secret key. Your router uses that key to scramble all your data into unreadable gibberish before it sends it out. Then your device uses that exact same key to unscramble it on the other end. To anyone without the key, it's just meaningless digital noise. That's why having a strong password is so important. It's literally the lock on your digital front door.
On top of that, modern Wi-Fi has a couple more really clever tricks. You've probably seen those routers that look like spaceships with all the antennas. That's for a tech called MIMO, which uses multiple antennas to send and receive multiple streams of data at once. It's like opening up more checkout lanes at the grocery store. Then there's beamforming, which is brilliant.
The router can actually detect where your device is and focus the signal directly at it, like a spotlight instead of a bare bulb, for a much stronger connection.
So we've seen how Wi-Fi works right now, but this technology never ever sits still. So let's take a quick look back at where it came from, and more importantly, where it's headed next.
You might be surprised that this whole journey really kicked off back in 1991, with Australian scientists making the key breakthrough and sending data clearly over indoor radio waves. By 97, we got the first official standard, and then in 1999, the marketing wizards gave it the catchy name Wi-Fi, and the rest is history.
Now looking to the future, get ready for this number. The next generation, known as Wi-Fi 7, has a theoretical top speed of 46 gigabits per second. Now that is just a mind-boggling speed. It's not just about downloading a movie in the blink of an eye, it's about powering the future. Things like truly seamless virtual and augmented reality, streaming multiple 8K videos at once, and having literally dozens of smart devices in your home all talking to each other instantly, without a single glitch.
And you know, the future of Wi-Fi isn't just about raw speed. It's about getting way smarter and more efficient. New standards are opening up brand new, less crowded frequency bands. There are new features that let your devices sleep to save massive amounts of battery. Routers will even use AI to manage traffic all by themselves. And there's even a wild new tech on the horizon called Li-Fi that uses the light from LED bulbs to transmit data.
Which kind of brings us full circle, doesn't it? From just wiggling a radio wave to send ones and zeros to managing an entire house full of smart gadgets, Wi-Fi has completely transformed our world. And this quote just says it all. It's not magic, but the science behind it is just incredibly cool. So, there you have it. From radio waves to routers, modulation to encryption, that is how the internet actually flies through the air. And it really makes you wonder, as our world gets more and more connected, demanding more from everything, what will the next invisible magic look like? Thanks for joining me for this one.